All right, here we go. Algebra 2, Unit 2, Lesson 1. We've got the kind of like keyword is functions, okay? So again, we're going to be talking all about functions and how they relate as well as their domain and range. So again, domain, we can think about as the inputs, and the range we can think about as the outputs. So I'm going to talk about that a lot when we talk about functions, inputs and outputs. Again, domain is like your X values, and then your output, your range is like your Y values. So there's a couple different ways you can describe functions or you can talk about functions. One way is with an ordered pair. So if I look at this, again, that would be like saying, hey, I have -2 and 2. I have -1 and 4. I have 0 and 8, so on and so forth. So that's one way you can show functions. Another way is with a table. So if I were to look at the table, I'm going to have X coordinates. I'm going to have Y coordinates. So I might say, hey, -2 for X, +2 for Y. -1 for X, +4 for Y. I might have 0 for X and 8 for Y. A third way, change colors here. A third way may be through a graph. So if I look at my graph, I might have, an X and a Y axis. And we said, what did we say? That at -2, we had +2. So right here, at -1, we said we had +4. And then at 0, we said we had 8. So 5, 6, 7, 8. So it could be somewhere up here. So again, ordered pairs, tables, graphs. The final kind of method that we can represent functions with is with a map. And again, it might be a little different definition of a map. It's like a mapping diagram where I'm going to say I've got inputs. So say my inputs are -2, -1, and 0. And then I've got my outputs, and I might say that they are 2, 4, and 8. And again, it might be like, hey, here's my output, here's my output, here's my output. So those are the 4 different ways that you'll see functions represented. Now, how do you identify a function? What is a function? So a function has a unique output for each input. So what does that mean? That means that no matter what my input is, I should get a unique output. So if we look at kind of like the mapping diagram, okay? So let's say we've got -3, -1, 2, and 4. Our outputs might be 2, 3, and -4. So, for example, let's say I input -3, I get an output of 2. Awesome. Let's say I input -1, I get an output of 3. Awesome. Let's say I input a 2, I get a -4. Totally okay. And because I have a different input, I input 4, but I also get -4. That's okay. This is a function. Yes, okay, function. Let me show you an example of something that's not a function. So if I take my inputs and let's say that I've got -2, 1, and 4, and then I've got my outputs as -4, -1, 2, and 3. And for this example, I'm going to say, hey, if I input -2, I get an output of -4. But in this case, I input a 1, I get a -1, and I input a 1, but I get a 2. Right here, I can see I've got 2 different answers. So because my input is the same, but my output is 2 different answers, this is not a function. Okay, so you can't input the same thing and get a different result for it to be a function. It doesn't work. That's not a function. Another way we can test if things are functions or not is through the vertical line test. So I'm just gonna draw kind of a normal parabola, okay, something like this. And the vertical line test is like if you took your pencil and you held it vertically and you just moved it. So again, I should only like come in contact with my graph at one time every time. So vertical line test only touches my graph one time, only touches my graph one time, only touches my graph one time, only touches my graph one time. Okay, so again, that's called the vertical line test. So this passes VLT, vertical line test. Here's an example of a graph that would not pass the vertical line test. Say we had a graph that looked like this. Okay, right here it passes, right here it passes. Here it does not pass, okay, because I touch my graph 1, 2, 3 times. So does not pass the vertical line test. So again, this would not be a function. You could not call that a function. Okay, so again, there's a couple different ways that we can kind of classify or look at functions. So we might get an equation. Let's say f of x equals -x squared subtract 2x plus 7. Now I see that this has an exponent, so I know it's not going to be linear because it's got an exponent of 2, so it's going to have some type of curve to it. And then if I wanted to evaluate this, okay, so this is a function, but I want to evaluate at x equals -4. So every time I see an x, I'm going to rewrite my problem and plug in a -4. So -4 squared minus 2 multiplied by -4 plus 7. So this is -4 squared, -4 times -4, positive 16. -2 multiplied by -4 is positive 8. And then I'm also left with plus 7. Whoa, almost dropped my iPad. So now I'm going to finish -16 plus 8 plus 7. -16 plus 8 is -8 plus 7 equals -1. So this function at f of -4 equals -1. I input -4, I output -1. And again, you could graph it, you could create a table, you could plug in different values, you could plug in -3, you could plug in 0. It's totally possible to graph or to find different solutions. All right, so one last example here. A diver using a diver propulsion vehicle, so like an underground kind of submarine thing, descends to a depth of 130 feet. The pressure in the atmosphere, because as you go deeper, the pressure increases, is given by the equation P of D equals 1 plus 0.03 D, where D is depth in feet. Okay, so D equals depth. And so we want to graph the function and determine a reasonable domain and range. What is the pressure on the diver at a depth of 33 feet? So again, if I were to graph this, okay, so my graph would look something like this. Let's say we've got 0, say we've got 2, 4, and then again, this is my pressure. And then this is my depth. I'm going to count by 40s, 40, 80, 120. So again, if I think about it, okay, I say, okay, I'm going to start here, and it's going to be a linear equation. It's going to look something like this. Because the depth varies from 0 to 130 feet, I'm actually not going to include this arrow because I'm going to stop at 130. So again, if you think about it, it's right here. This is 130. So the reasonable domain would be from x is 0. X could be 0. Okay, so here's my domain. Domain is the x values. So x could be 0, and x could also be 130. But it's not going to be any bigger or any smaller than that. So if I look at the pressure and I say, so now I got to figure out the range. So again, the range is the y values. So if I plug in, if I say, what is my pressure at x equals 0? Well, that's going to be 1. So my pressure at x equals 0 is 1. And then my maximum value at x is 130. We're going to call this, well, we're not quite sure. We got to figure out what that is. So now we're going to use our equation. We're going to say, well, what is it at 130? So I'm going to take this equation right here, 1 plus 0.03, and every time I see a D, I'm going to plug in 130. So when I do this, I get 1 plus 0.03 times 130 is 3.9. So this equals 1 plus 3.9, which means that my pressure at 130 is 4.9. So my range, again, that was our question, is what's the domain and what's the range? We got the domain right here. The range is going to go from 1 all the way to, so I'm going to say that this is P of D, also known as my y values, to 4.9. So that's how you calculate the domain and the range. The last part of the question is, what is the pressure on the diver at a depth of 33 feet? So I'm going to take my equation, P of 33, and every time I see a D, I'm going to plug in a 33 and solve it. So 0.03 times 33 is 0.99. 1 plus 0.99 equals 1.99. So I could say at a depth of 33, the pressure on the diver is about 1.9, it is 1.99, or about 2 units. And in pressure, we call it atmosphere. So I would say approximately, a squiggly equal sign is approximately 2 units of atmosphere.